Howdy. Where am I? Alright, so the first step in this process is to get our data. The amount of data needed to actually train this model was pretty staggering. Images were taken across 500,000 simulated rounds of Geoguessr. I actually needed to pick up a 5TB hard drive just to store the image data. To put that into perspective, if it took you 10 seconds to complete a round of Geoguessr, and you spent 12 hours a day guessing locations, it would take you over 115 days to catch up. I also recorded the latitude and longitude of each location that we want to train the model to predict. We can also convert the latitude and longitude into Cartesian coordinates. Here's a quick visualization of just 10% of our training data, each point representing a location that we want to train the model to predict. We're going to be working with a model known as a CNN, or a convolutional neural network, which is actually inspired by the same process that humans use to interpret visual data. In the same way that your eyes will focus on one portion of an image at a time, convolutional neural networks use what's known as a kernel to isolate specific portions of the image and extract patterns. The first step we have is to split the image into red, green, and blue channels. After some normalization and reshaping, we can pass the images to the network. The specific architecture that we're going to be using here is a modified 50-layer ResNet, which is going to output our predicted latitude and longitude. One thing I think we can do to improve performance is to actually extract the text data within the image and process it as an additional input. To do this, I'm going to use a process known as optical character recognition. My plan here is to use one model to extract the readable text from each image and another to predict what language that text belongs to. We can then map these predictions to countries that speak that language and add that to our previous guesses. So let's start training. Alright, so after reviewing the training data, I think we can make some changes. We're getting great results for the most part, but sometimes the model outputs some pretty rogue predictions. This is because we're evaluating the model based on the distance between the predicted coordinate and the target coordinate. The loss function we're using is the mean squared error, which is essentially a distance calculation within this context. Because of this, all points along the circumference of this circle are equally as accurate. This results in some pretty funky predictions. To overcome this, we're going to transition from a regressive model that predicts the latitude and longitude of each coordinate to a classification model that predicts what region the coordinate exists in. First, we divide the world into a regional grid. Each square in this grid represents a possible output from the model. Because we're no longer working with a regressive model, our network will now generate a list of values that represent the probability that each square contains the target location. We can then color code the grid based on these predicted probabilities. Let's also increase the number of layers in our network from 50 to 152, which in turn will increase the number of trainable parameters from 25 million to over 60. Alright, so our model's finished training, so it's time to test it out. To do this, I'll run the model against a series of challenges, which I'll also give a shot. Full disclosure, I'm not terribly great at geography, so if I do embarrass myself, cut me some slack. Okay. Does it say latte on it? Transporting. Oh, it's transporting milk. We're in Italy, I think. Right? If I'm not misreading that, we're in Italy. Okay. But I've got no idea where. Probably north. I think that's where they have most of their dairy farms. Yes. Okay, we were in Italy. We were near Naples. Okay. Look, I'm okay with that. It's a good start. It's a good start. I'll take it. Based off one image, can't complain. Okay. I am completely lost. Europe, for sure. But that's about as far as I'm getting. Could we be in Austria? In Graz? Potentially? Maybe? No. Not even close. We were in France. Okay. And I'm stumped on this one. It's a very wide road. I'm gonna say we're in Canada. Maybe near Vancouver? Potentially? No. Not quite. Wow, Nevada. Interesting. Okay, we started off strong and we've kind of fallen off a little bit, but that's okay. I have no idea. I have no idea. We are probably maybe in Slovakia. I'm gonna say probably closer to the eastern border. Not quite. Not quite. I have no idea. This could be anywhere. I think we are in Europe. I think we are closer to the north. I'm gonna say we're on the way to Denmark, but this is a complete guess. Finland. Yeah, okay. Not great. Not great. I think I dropped the ball on that one. Started strong. I think the AI's got me on this one. We'll see. I'm not really liking my odds though, to be honest. Okay, let's see how the model performs for the exact same map. A huge spread across Europe, it looks like. This could be anywhere. It's slightly off, goes France. France instead of Italy. Still gets 2800 points though, so it's not too shabby. Europe again. It predicts Germany. And again, should have gone France. You had it before. Gets more points though. It's on 3,000 points. It's still doing really well. And it looks like it actually guessed France correctly, but the Gaussian smoothing moved it slightly to the east, if you look at the heat map. I think the snow's gonna throw it off here. Wow. I'm actually quite impressed it got that, to be honest. I don't think I have a huge amount of snow in the training data set, so that's actually pretty impressive. We're applying a Gaussian filter and then taking the weighted sum of predictions, so there might be a better way to do it, but okay, it seems to think Ukraine, it looks like. Yeah, it goes Ukraine. Just needed to be a bit more north. Alright, final one. And it's super confident. It looks like it's going Finland. Wow. Not bad. Not bad. Just based off one image as well. Damn. That's actually pretty cool. Alright, let's see if I can bring it back. And we still can't move or zoom in. I think we're somewhere in Mexico. I'm gonna say further south. I've got no idea though. Complete shot in the dark. More north. Not a terrible guess though. I mean, given the conditions, not a terrible guess. I take it. I'll take it. Okay. This is pretty shocking. I have no clue where we are. Somewhere in Europe, I assume. But apart from that, I'm pretty lost. Could we be? I don't know. I'm gonna say somewhere in Spain, but Luxembourg. Really? Right on the border. Oh. Okay. Okay. This is gonna be a complete shot in the dark. Maybe Jordan? I'm gonna say we're in Jordan on this road right here. That's pretty good. That's not bad. We were in Jordan. Excellent. All right, I'm stoked. That's great. All right, 4 out of 5. We are somewhere in Europe with really, really nice roads. So somewhat bougie. Somewhat bougie. Could we be potentially in Belgium? Somewhere near Brussels? We were not in Belgium. We were in Germany. But 4,000 points, I'll take it. I'll take it. And I've got no idea. I've got no idea, and the time pressure is getting to me. I'm gonna say that we are in Italy somehow. But this is wrong. It just feels wrong. I'm just gonna send it. Oh, it was Italy. Not too bad. A couple lucky yeses there, but I'm pretty happy with that. Alright, let's load up the model and see how it performs. Okay, last round. It seems to think America or Mexico. Pretty large spread along that west coast though. Not bad. Not too bad. I think it's actually better than my guess, somehow. There is probably an upper limit to the performance due to the grid size, beyond which you'd probably need to do some kind of refinement. This one's going to be pretty challenging. You can see the spread across Europe is quite large. Not too surprising there. Based off one image as well, I'm not too shocked by that, to be honest. I think we're pretty neck and neck at this point though, just based on the difficulty of the images. This might throw it. No, it's super certain. You can see in the heat map, it's all condensed into one square. Israel and Lebanon probably occupy the same grid, so that's probably a perfect guess on the model's part, or as close to perfect as we can get with the current architecture. Alright, probably, oh, it's very confident. Wow, another perfect guess. Yeah, Germany, well done. That's definitely within the same grid, or at least within one square. Okay, this is also quite challenging, but it seems to think northern Italy or along the border. Yeah, and that's where it guesses. Again, a very good guess. This is probably close to perfect when you consider the grid. Wow. Quite a few perfect guesses there, which is super surprising considering it's only got a single image to go off. Alright, so the model completely destroys me, but not too surprising, I guess. This project was quite a lot of fun. If you guys want to learn more about the models that I used, feel free to reach out. Otherwise, thanks for watching.